In this video, I'll show you how the color of the sky and the color of the sun have a reciprocal relationship. And it's in my book, the art instruction course, Color and Light, which is only $7 on Amazon. Since we're going to talk about the color of the sun and the color of the sky, we're actually talking about the color of light. So we need to use the additive color wheel. The primary colors in this wheel are blue, green, and red, just like the cones in our eyes that see light. The secondary colors are cyan, yellow, and magenta, which are also the colors of the ink in our printers. And how these relate are discussed in my video 130 about the additive color wheel. Now, the complementary color to cyan is red. The complementary color to yellow is blue, and the complementary color for magenta is green. The sky colors depend on the depth of the atmosphere and the type of air molecules that are scattering the light. So at the zenith, light travels through the thinnest amount of air, encountering the fewest molecules. While the upper atmosphere scatters both violet and blue light, our human eyes are more sensitive to blue light than violet light, and that's why the overhead sky looks blue. As the view shifts downward, the light travels through an increasing volume of air, and in this intermediate zone, the violet and blue light are scattered so that the sky shifts towards a cyan and even a little bit of a green color. At noon, the horizon is a hazy white, but at sunset, the blue wavelengths are lost, leaving the red-orange light to take over. And at the lowest part of the horizon, we get a rose-gray color due to dust and smoke from the ground. As for the colors of the sun, at the zenith, it is white, and as it goes down, it shifts toward a pale yellow, then an orange, and then finally a red, which is its most intense color. The sky is due to light that is scattered out of the sunbeam. So this blue skylight is due to blue and violet light that is scattered away from the yellow sun. And the sun is colored by the rays that manage to survive that filtration. So here the sky is blue, and so the remaining light colors, green and red, combine to make a yellow sun. As the sun sets and goes through more atmosphere, the green light begins to scatter away in addition to the blue light. So you start getting a light blue sky, and then when you add more green, then you get cyan, which is the mix of blue and green. Now, since you're losing some of the green to the sky, the sun has less green, so it becomes yellow, orange, or orange. When the sun is just about to disappear below the horizon, it becomes a red-orange sun. And you would expect that its complement, cyan, would be the color of the sky. But by this time, there's very little light in the atmosphere, and so everything starts getting dark. And in addition, the ozone layer in the upper sky keeps the sky appearing blue. The sunlight is pure white before it reaches our atmosphere. And then it gets divided up into what the sky takes from scattered light and what the sun keeps in its direct sunbeam. So at high noon, we have a small amount of blue and cyan light scattered, whereas at sunset, we get a massive amount of blue and green scattered. And what the sun keeps is the rest. So at high noon, it becomes a warm yellow, and at sunset, it becomes a red-orange. And this plus this equals white light. Please remember to subscribe and check out my book, Color and Light, on Amazon. I'll leave a link to the book at the bottom of this video.